All right, boys and girls, welcome back to 2026. Let's hear it for 2026. All right, now take your hands and put them on top of each other like this. Your hands are they congruent, similar, or both? Come on, think about what those words mean.
Congruent.
Your hands are congruent, but are they similar?
Yes.
Yes.
They're both.
They're both. So look, congruent means same shape and same size. You can put one over the other and it covers it perfectly. Now put your hand up against somebody who's not your hand, if you will, if you want to. If your hands are not the same length, now they are similar to each other. Does that make sense? Unless you're Mr. Ostendorf, it's the same shape as your neighbor, but it's probably a different size. That's what similarity is, okay? A dilation is when you take the shape of something and change the size without changing the shape. You guys know all about dilations because you've been bottom right dragging things your whole life. You know what I mean by that? When you take an image and stretch it right, it makes it look totally fat. If you stretch it up, it makes it look totally thin. But if you stretch it from the bottom right corner, it gets bigger without losing its shape. That's exactly what a dilation is. Where have you heard that word dilation before? Where do you get dilated in your body?
Eye doctor.
Yes, your pupils. Okay, or during birth, you get dilated. What that means is showing that your eye shape is not, the shape isn't changing, but the size of your, is that pupils or retinas? The size of your pupils is changing. Does that make sense? Okay, that's pretty much this is very vocabulary built. What do they want us to do here? How are the sticker and the car? Okay, yeah, look. This would be a dilation. Okay, these little stickers are a dilation of the big one. So it's important to know that when you multiply something by a number that's positive but less than 1, what happens to that thing? What if you multiply by a number that's positive but less than 1? It gets smaller. If you multiply something by a half, it gets smaller. So here you'll notice that our black triangle ABC has gotten smaller to get to A prime, B prime, C prime. Let's look at how we do that. We take a point, we connect PB, PA, and PC, and then we bisect each of those segments, and those new bisection points is what allows us, with a construction tool, to dilate a figure. Look, you can start with any point here, point P. Okay? So now, look at the red one. Do you see how the red one has these tick marks? W prime, X prime, and apostrophe, if you will. So that means the red one is the original one or the new one? The new one. So is our scale factor going to be more than 1 or less than 1? More than 1. And in this case, it looks like it's 2. Also, does this look three-dimensional to you guys? It does to me. So now they're going to let you try it. This is always fun, but this video is getting kind of lengthy, so I'll let you guys try it. This is just going over exactly what we talked about. So if n is less 1, the dilation is a reduction. If n is greater than 1, then I don't know what they call that, an expansion? Okay, I think we're about through it. The scale factor, again, has this thing gotten bigger or smaller? It's gotten bigger. So to find the scale factor, since it's getting bigger, you just use similar sides. 18 to 12 is our factor, but we can reduce that to 3/2. So this has been a dilation by a factor of 3/2. Boink, boink, doink. Okay, now look, now we're on the coordinate plane. You see that? So now to dilate from the origin, all you have to do is take the coordinates and multiply by a dilation. So this says, what are the vertices of dilating this triangle by a factor of 3? So what we had to do is we had to find the points. So for example, point A was at 2, -1. Multiply those by 3. Our new point A will be at probably 6, -3. So to dilate it, all you got to do is multiply the numbers in the ordered pair by the dilation. Does that make sense? So if we want to dilate this by a 4th, if I did it very quickly, the point -4, 0 will become -1, 0. Don't save that, just draw it. The point 8, 4 will become the point 2, 1. And thanks for using nice numbers. The point 12, -4 will become the point 3, -1. And now if I draw this accurately enough, you can see that that red triangle has been dilated by a factor of 1/4. Whoops. Doinks. Doinks. Froinks. Ooh, now this is going to be a tougher one. Dilate a figure with the center. So dilate, what happens if we dilate this at 1/2, scale factor of half, so that the image point is half the distance from R to the corresponding. I tell you what, when you get to these, I will help you individually or I'll make a separate video. It seems like this is kind of complicated, but I bet you guys can figure it out. Because we're running out of 5-minute time. This is a long one. 12 slides? Don't know about that. Okay, I think that's good. We got what we needed. Can I get a boom on 3? 1, 2, 3.
Boom.